Hi all, I'm K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, we are going to see about the modified OSI model for the IoT and M2M systems. It's an important concept in wireless technologies for IoT. We already know that the traditional 7-layer OSI model was designed mainly for conventional computer networks. However, IoT environments are very different. They involve resource constrained devices, low power operation, and large scale connectivity. So today we will see why the OSI model needs modification and how simplified IoT specific architectures are used in real world applications. So let us begin with the challenges faced in the IoT environments. First is resource constraints. Most IoT devices such as sensors and actuators have very limited processing power, memory and storage. Implementing all the 7 OSI layers on such devices becomes impractical. Second is power consumption. Many IoT nodes operate on batteries or energy harvesting. Running complex protocol stacks continuously would drain the power quickly. Third is low bandwidth. So IoT networks often use technologies like Zigbee or LPWAN, which support very low data rates. So the overhead of the full OSI model increases latency and reduces efficiency. Because of these limitations, the traditional OSI model does not perfectly fit the IoT systems. To overcome these challenges, researchers and industry experts proposed modified OSI models for IoT. So instead of strictly following the 7 layers, layers are merged or simplified. The goal is to reduce complexity while still ensuring reliable communication, scalability, and interoperability. These modified architectures are optimized specifically for machine-to-machine communication and large-scale IoT deployments. So now let us look some commonly used modified OSI models. One is the 3-layer architecture, which is the simplest one, which consists of perception layer, network layer, and application layer. This model is easy to understand and widely used for basic IoT systems. Another one is the 5-layer architecture, which provides clarity and control. So the 5 layers are perception layer, transport layer, processing layer, application layer, and business layer. So this structure separates data processing and business logic, making it suitable for enterprise and industrial IoT systems. So it is show comparison between the traditional 7-layer OSI model and the modified IoT model. So in IoT, physical data link and parts of the network layer are often merged. Session and presentation layers are usually eliminated and application specific protocols handle data formatting and security. So this results in compact, efficient architecture that meets IoT requirements without unnecessary overhead. Now, let us briefly understand the key layers in the modified IoT model. So, the perception layer interacts directly with the physical world. It includes sensors, actuators that collect real-time data such as temperature, humidity, or motion. The network layer is responsible for transmitting this data using the technologies like Wi-Fi, Zigbee, LoRaWAN or cellular networks. The processing layer performs data storage, analytics and decision making, often using cloud or edge computing. Finally, the application layer delivers meaningful services to the users, such as monitoring the dashboards, alerts, or control applications. To validate these models, we apply them to the real world scenarios. So, in smart home automation, sensors collect the data, Zigbee or Wi-Fi transmit it, a local hub or cloud processes it, and users interact through a mobile application. In industrial IoT, sensors monitor machine health. Data is transmitted using MQTT or 6LoWPAN, processed at the edge or cloud, and displayed on control dashboards for predictive maintenance. So these examples show how the modified OSI model works efficiently in practice. To conclude, the modified OSI model for IoT M2M systems simplifies the communication architecture to match the constraints of IoT devices. So this is a sum of whatever we have seen. So by reducing the layers and optimizing the protocols, IoT systems become scalable, energy efficient, and practical. Hope you understood the modified OSI model. So let us take up some assessment questions. So first one is, which layer is a typical IoT model that deals directly with physical sensors and actuators? So the options are network layer, perception layer, application layer, and transport layer. The answer is perception layer. Next question. In the context of IoT and M2M, what is the primary role of the application layer? The options here are packet routing, error detection, providing user-specific services like monitoring and control, and physical data transmission. Yes, the answer here is the primary role of the application layer is to provide user-specific services like monitoring and control. Thank you for watching this video.